So today what we're going to be doing is we're just learning about I can identify linear functions and linear equations. We just talked about in that exploration worksheet that we did. We reminded ourselves what a function means. Can anybody state again the definition for a function? Because it's kind of important. We're going to have to determine if something is a function or not. How do we make that decision? Anybody remember the definition for a function? Let me search out. Each x value has only one y value. Thank you, Blake. Each x value has only one y value. Each domain value has exactly or only one range value, also known as a y value. So when we have a function whose graph forms a straight line, we call it a linear function. There are many different types of functions, but when we have one whose graph forms a straight line, such as the one just did in our exploration, we would be able to state that it is a linear function. So everybody needs their book open, it looks like, to page 230. And we're going to be doing the check it out problem at the check it out ones at the bottom of the page, where the directions tell us to identify whether each graph represents a function and explain. If the graph does represent a function, is it linear? Well, how would we determine if it's linear? What's going to make up a linear graph? What's it going to look like? Straight line, yeah, it's going to be a straight line if it's linear. Okay, so first thing we're going to decide is it a function or not? And the second thing we're going to decide then, oh, if it is a function, then is it a linear one? So the first thing I want us to do in 1A is off to the side here, we want a rough sketch of what that graph looks like. So it appears to be a line rising from left to right. So let's just do a rough sketch of that off in our margin. And then the first thing we have to decide is, does that represent a function? So, what do you think? Does this graph represent a function? Anybody remember what test a graph had to pass to be considered a function? Anybody remember a graph test we did? We draw vertical lines going to the graph. Just a whole bunch of vertical lines going to the graph. What do you think has to hold true? That vertical line, each vertical line can only do what? Only cross through the graph at one point. So each vertical line can only cross through that graph in one spot. So if I went right now and started drawing some vertical lines through this graph, this one would cross right there, wouldn't it? If I did another one, let's say right here, it would cross right there. If I could draw an infinite number of vertical lines going through that, would each vertical line only cross the graph in one spot?
No.
Okay, give me one that you know, draw one that you think would cross in more than one. What do you think? You got one that would cross in more than one spot? Okay. So we're going to say yes, it is a function. Because we have to explain whether it is or it isn't, we have to explain. We have to do a because every time. Because each x value, that's our definition, each x value, so we have a point, only one point that it's crossing at, that's the only time that x value is going to get used. Each x value has only one y value. I thought we had probably written that enough times in the previous lesson that we would never forget that. It's a function where each x value has only one y value. Okay, well then it says, if the graph does represent a function, is it linear? In other words, is it a straight line? Is it? Yes, okay, so we would say, yes, it is linear. It forms a straight line. That's not an if there, it kind of looks like an if, it's an it. It forms a straight line. So, yes, it's a function because each x value has only one y value. Well, now that we've determined a function, we're trying to decide, is it a linear function? Yes, it is linear. It forms a straight line. So we have two explanations that we had to make here, right? So we're going to make two explanations every time, whether it is a function or not, okay? Okay, 1b, would you sketch in the margin what that graph looks like? Sketch in the margin what that one looks like? What kind of a, what's that called? Anybody know what that type of line is called?
Parallel.
No, it's not parallel. Is there anything else that's parallel too? What kind of a line is that? That's a straight line, yeah. What kind of a straight line is it? You don't know? Horizontal, yes, it's a horizontal line. Okay, so what do you think? Do you think this one is a function? Is this one a function? Yes or no? Would it pass the vertical line test? Ollie, what do you think? Do you think it would pass the vertical line test? Yes? So in other words, no matter where I drew a vertical line going through it, that vertical line would only cross one, it would only touch the graph one time. Adam?
Okay, so vertical means up and down, or?
Yes, so the vertical line means up and down. So just like I drew in the last one. If I draw a vertical line, it only crosses that in that spot. If I draw another vertical line over here, it's only crossing in that one spot. If I draw another one right here, it's only crossing in that one spot. Do you think it will ever cross in more than one spot? Any vertical line that I choose to draw? Yeah, so it's going to pass the vertical line test, which means each x value then only has one y value, so there's only one point. Only one time x gets used on that vertical line. So we're going to say, yes, it is a function because yes, it is a function because, what's the because?
Each x value.
That's right. You can, more than one, you can be speaking at a time. It's okay. Each x value has only one y value. Well, if it is a function, then we have to decide if it's a linear function or not. Linear? Okay, and why? Forms a straight line. So we're going to say, yes, it is linear. It forms a straight line. Okay. Let's do 1c now. Sketch it in the margin. Sketch 1c in the margin, please. Okay, and then the next thing we do is we decide if that represents a function or not. It's not a function? No? Why not?
Because it's not a string. Because each x value is new data. Yeah, because
How many times will that cross through that graph when I drew? Twice. Are there any other times that would happen? Yeah, actually it would happen several times, wouldn't it? So what we're going to say is no, it is not a function. And we will say several, we can't name them all, several x values will have, did you catch up? No, it is not a function. Several x values will have two different y values. And they can only have one. So several of our x values will have two different y values. And we have to say different because, you know what, sometimes there are ordered pairs that make up a relation that the x's are the same and the y's are the same. So we have to talk about several x values will have two different y
That
values.
means it's not linear because
So now that it's not a function, do we even have to decide if it's linear? No. Actually, it says if it is. So I stated wrong earlier when I said you had to do two explanations for every one. It says if the graph does represent a function, then we have to decide if it's linear. If it's not a function, we don't even have to decide. But is it linear?
no.
No, it's not, is it? Okay. Are all straight lines a linear function then? Do you think we can come to the conclusion that no matter what straight line you had, it would be able to be considered a linear function? So the real question is, first of all, can all lines be functions? Can you think of any lines that would not pass the vertical line test? In other words, an x value would have more than one y value.
Can it have more than one? Like a triangle? Can that be like, does it have a whole bunch of straight lines?
Okay, no, I want
No,
to
that wouldn't count.
on a triangle, basically, then we would say it's made up of three linear functions to make that triangle. Okay, so I want
Give
just,
this to-
this is the question we want to answer. Are all straight lines?
Yes.
No. Hey, Preston, what kind do you think would be?
Like up and down a straight line.
Oh, like an up and down called vertical, right? If we had a vertical line, let's draw that. If we had a vertical line, could that one be, even though it's a straight line, we could say it's linear, but could we say it's a function? No. A vertical line is linear, but is not a function. Okay? Let's see if it'll let me come back and write some more again. Okay, a vertical line is linear but is not a function. One x value, that's all that's on this line, there's only one x value. One x value has several, an infinite number, several different y values. So one x value, every point of that line has the same x value. That one x value has several different y values. So whenever we have a vertical line, we cannot call it a linear function. We can say it's linear, but we cannot say it is a linear function. Okay? Anybody think there's any other type of straight line that would not pass the linear function test? We already had a horizontal line and it passed it. We had one that was rising from left to right and it passed it. How about a falling from left to right one? Do you think that one would pass the test? It would pass the test for being a function. So it appears the only type of straight line, the only type of linear graph that is not a function are our vertical line ones. Okay, so anybody have any questions about what would be the expectations when you're doing problems like this in your homework? Because you will be doing problems like this in your homework. let's see what other type of thing you're going to be doing. To determine if a table of values, so now you don't have graph. Now you have a table, and you probably don't want to go through all the work of graphing it. If you have another way you can go about it, to determine if a table of values is a linear function, you're going to look for a constant change in x. So if there's a constant change in x that corresponds to a constant change in y, you can say this would be a linear function. It would, if I graph this, it would be a line on a graph, and it would pass the vertical line test. It would be a function. So here's the first one we're going to practice. We have this table, -2, 9, -1, 6, 0, 3, and 1, 0. How many ordered pairs do we have there? How many points would that be on a graph?
4.
4. Okay? So let's look at the x's. What's happening as we go from -2 to -1? What's happening? Add 1. To go from -1 to 0, add 1. To go from 0 to 1, add 1. This is looking for a constant change in x. So we're going to say as x goes up 1, that's what we just discovered, that the x's are going up 1. So this is the work we're going to show. As x goes up by 1, let's check out and see what happens with the y's. To get from 9 to 6, what's going on? Subtract 3. To get from 6 to 3, subtract 3. To get from 3 to 0, subtract 3. So as x goes up by 1, y does what? Goes down 3. Yeah, goes down by 3. So we're going to say goes down 3. So if we graph this, do you think it would be a linear function? Does it meet the standard of is there a constant change in x that corresponds to a constant change in y? So in other words, they don't have to match. If x's is going up by 1s and y's are going down by 3, they don't have to be going by the same number and in the same direction. They just both have to have a constant change. So x has a constant change of +1, y has a constant change of -3. So we are going to say that this is a linear function. And our work supports it. So we have our table, we're showing what's happening to the x's, we're showing what's happening to the y's, we state it. We say as x goes up 1, y goes down 3. Therefore, I can say this is a linear function. Because it meets the standard that says a constant change in x corresponds to a constant change in y. So any questions on that one? Okay, and that one they already gave it to us in the table. What if they don't? So if they give it to us as a set of ordered pairs, I'm insisting this is what you do. Write in a table and check the change in x and change in y. It's going to get way too messy trying to leave it as a list of ordered pairs. So we're going to make this nice vertical table like the last one had. So we're going to go put our ordered pairs in there. We have -4, that has a y value of 13, -2, 1, 0, -3, 2, 1, 4, 13. So we're making a table so we can show our work. Okay, go ahead and show your work. What happens to the x's? What happens to the x's in this table, in this set of ordered pairs? Remember the trick when it's, negative numbers, think about it as our cold winters we had in North Dakota, below 0 temperatures. Okay, according to my work, I say that x keeps going up by 2. Do you agree? Okay, let's check out the y's then. What happens when we go from 13 to 1?
Subtract 13.
Subtract 12.
Oh, yes.
Yeah. 1 to -3. Subtract 4. It's 1 above, it goes down to 3 below. The temperature dropped 4 degrees. From -3 to 1, add 4. So this time we're adding 4. From 1 to 13,
Add 12.
add 12. Is this linear? Is this a linear function? No. And we're going to say not a linear function. We can't talk about a constant change. So we're going to say not a linear function because there is not a constant change in y. This should remind you of arithmetic sequences. When did we determine that a sequence was arithmetic? When what? When did we decide that a sequence, a list of numbers, was arithmetic? That was just last lesson of the last chapter, folks. Last quiz. When did we decide that a list of numbers, a sequence, was arithmetic?
Arithmetic sequence is the numbers with the common difference between each number.
Oh, the common difference. So you know what's happening here? We're looking for a common difference. We're looking for a common difference. If it doesn't have a common difference, it's not arithmetic. If it's not arithmetic, it's not linear. Let's go back up to this one. As these, it's kind of like term 1, term 2, term 3, term 4. What was happening? Here's our common difference. We would have called this one arithmetic. If I would have given you this list of numbers, you would have said it was an arithmetic sequence, 9, 6, 3, 0, because it had a common difference of -3. So it's kind of like, if it's an arithmetic sequence, if the y values, when we have that constant change in x, if the y values can represent an arithmetic sequence, you should have yourself a linear function. Okay? Okay, anybody have any questions on what kind of work you need to be showing in your homework for these types? Can you leave a list of ordered pairs as just a list of ordered pairs before you determine the constant change or not? No, you have to do what with it? Write it as a table and do just like we were doing with these in the note. Okay, then let's get you started on your homework.